Question 6. For the equation y equals 8 times 2 to the power of x, complete the table and plot the ordered pairs on the graph. All right, so let's think what's going on here. What is happening here with this exponential equation? First off, guess what this number is here. What do you think we always put at the beginning? What goes at the start? The beginning. Here's where we start at the beginning. So apparently there was 8 of these things. Now my question for you is, where does the 8 go? Does the 8 go here at 1 day? Has it been 1 day since we saw 8? Or does 8 go at day 0, the start, right? Where is the start? Well, the start happens at the vertical intercept. That's at 0. 0 days have passed when we're starting with 8. If you say 1 day already passed, you're not at the start anymore. You're a day later. At the start is at 0 time has passed. So 8 is going to go right here, right? We're beginning at 8. Here's our vertical intercept on our graph. When when x equals 0, because 0 days have gone by, y equals 8. Now, why is that true in the formula? You don't really don't stress out about this if this confuses you. But look, anything to the power of 0 is 1. So if we plug in 0 for 0 days, or whatever this time is, 2 to the power of 0 equals 1. And 1 times 8 equals 8. So you can either remember that by plugging in 0 for x, or you can just remember, hey, I know how exponential functions work. This is where we're starting at. It's going to be at day 0. We got 8. And it says times 2. We're going to keep multiplying times 2 times 2 each day that goes by. Okay, so a lot of you, I'm sure for many students, it's probably just easiest to think, what's 8 times 2? Well, 8 times 2 is 16, so it's doubled after 1 day. And then it's going to double again. 2 times 16 would be 32. And then 2 times 32 would be 64. And I think that's probably the easiest way for most students to feel comfortable with figuring this out. Just look at you're just going to know, like, here's where we're starting with 8. And we just keep multiplying times 2 over and over and over again. That's the whole point of these exponential functions. But if you're the kind of student that likes to plug numbers into the formula, well, you're going to say 8 times 2 to the power of 1. 2 to the power of 1 is 2, times 8 is 16. And how do we get 32? We got 8 times 2 to the power of 2, right? This x is our exponent. It's going right up here. So 2 to the power of 2 is 4. 2 times 2 is 4. 4 times 8 is 32. And then next we've got 8. We're starting with 8. And on the third day, or whatever this is, we're going to have times 2 to the power of 3. And 2 to the power of 3 is 8. 2 times 2 is 4. Times 2 is 8. And we multiply 8 times 8, we get 64. Like I said, for a lot of you, you might just be most comfortable using your familiarity with this equation and just start with 8 at day 0 and then keep multiplying times 2, times 2, times 2. I think for many of you, it'll be a little more simple than trying to plug these things in here. Right? So how we're going to go backwards, all right? They're telling us we're double. Every day that we go forward, we're doubling each day that passes. So what would be the opposite of doubling? Doubling is multiplying by 2, and we're going to think, what's the opposite of multiplication? Division. We're going to have half as much. If you're having twice as much the next day, that means you had half as much the previous day. So for a lot of you, if you're familiar with how these equations work and you know that going backwards, instead of multiplying by 2, we're going to be dividing by 2 each day that we go backwards, you could just say, hey, what's 8 divided by 2? What's half of 8? And that's going to be 4. And then what's half of 4? Well, that's going to be 2. And what's half of 2? Well, that's 1. Now, let me show you where this comes from, okay? One thing they really wanted us to appreciate this year in Algebra 1 is how and why these negative exponents work the way they do. So earlier we talked about how 4 to the power of negative 1 equals 1/4. And 4 to the power of negative 2 is 1 divided by 4 squared. Well, down here, 2 to the power of negative 1, it gives us the reciprocal of 2 over 1, which is 1/2. It's the opposite of times 2. We got divided by 2. And then 2 to the power of negative 2 is 1/4. So let's write this in over here. What color we got? Green? All right. So 8 times 2 to the power of negative 1 is 1/2. And that's how we got the 4. But like I said earlier, if this whole part about plugging these numbers into the exponent intimidates you, just focus on your understanding of the equation and try to write it like that. But if you don't know how to do it both ways, that's even better. All right, next in purple, I've got 2. Half of 4 was 2. Where did that number come from? It came from the fact that we started with 8, and we're multiplying it times 2 to the power of negative 2. What's 2 to the power of negative 2? 1/4. And this is just a great way for you guys to get to appreciate that these aren't just silly rules, these negative exponents. They actually really make everything work perfectly in mathematics. So next, 2 to the power of negative 3 is 1 over 8. So we got the 8 we started with times 1/8. 2 to the power of negative 3. And guess what 8 times 1/8 is? It's 1. So everything all checks out here. If you do it both ways, you're going to know for sure you got it right because you can check your work like this. All right, how do we plot these points? Always remember, I see a lot of people struggle with graphs, but don't be intimidated. It's not really that complicated. Look, here's our y-axis. We count up or down whatever this y value is right here. That's why I put 8 right here. And 0, our x value, it goes left and right. How far left or right are we going to put this points? It comes from the x value. So how about this one? X is 1, y is 16. So I go over here. Remember, x is 1, and I go up to y is 16. But don't draw it like this. I see people put this on their tests sometimes. Don't put these lines. That's not the graph. We're just plotting the points. So what have we got? 1, 16. When x is 1, y is 16. And in purple, my next point is going to be 2. When x is 2, y is 32. So I look, where is x equal to 2? Where's y equal to 32? And over here, all the way on the right, I got 3 is 64. When x is 3, y is 64. And now let's go backwards. I'm looking at negative 1. When x is negative 1, y is 4. X is negative 1, y is 4. I don't have a 4 here on my graph. That doesn't mean I'm going to freak out and give up or not know where it's at. I'm just going to think, where would 4 be on this y value? When y is 4, I see an 8. And I know that 4 is half of 8. So this line right here must be where 4 is. So x is negative 1, y is 4. And then for 2, apparently when x is negative 2, y is going to be positive 2. When x is negative 2, y is positive 2. So positive 2 is about halfway up to 4. I don't know what just happened there. All right, and we got one more point. 1. This 1's going to be real close to 0. When x is negative 3, y is 1. And it's easy to plot points if you just practice it. You might have trouble with it at first, but if you keep practicing. And then here's the classic exponential shape. You know what's going to happen as the x values get smaller and smaller in the negative direction? You're just going to end up with these smaller and smaller fractions. This is never going to get to 0. It's just going to get closer and closer and closer to 0 as these exponents get really small in the negative direction. We just get these tiny little fractions with these giant denominators, but never quite reach 0. And this is exponential growth.